Hello, my name is Rafat Hossain, and on behalf of my team consisting of Talha, Tahseen, Zuhair Qureshi, and Dennis Liu, I welcome you to our analysis, and we are thrilled to share our outlook on our research. At a time when electric vehicles stand as a stepping stone for a progressive future, we've analyzed the impact of manufacturing emissions in the automobile industry on global sustainability. So stay tuned and enjoy. Our research content is as follows. We've ultimately narrowed down our focus on renewable energy and the impact of the ins and outs of EVs, starting with manufacturing and the rise of fuel prices. As more and more cars flood the streets globally, the negative external cost is often unrealized. We've identified that even though EVs are soon to become dominant, the manufacturing methods stand as a barrier to reaching carbon neutrality. We hope that solar energy usage will be efficient and economically viable in the long term. Furthermore, we've ultimately gathered data on the manufacturing of electric cars and the maintenance cost of electric and gas vehicles. It is important to note that our data was compiled from various government data sets and scientific organizations' data.
Now, to fully understand the transportation industry's impact on global sustainability, it doesn't suffice to focus solely on consumer emissions. What is required for a fuller understanding of vehicles and their impact on sustainability is a complete and unmitigated life cycle analysis. Life cycle analysis involves viewing the environmental impact of a product as the sum of all the emissions produced by itself and by all the means and methods of producing it, from material extraction to eventual disposal. A large part of our research will examine electric vehicles, or EVs, as they are often put forth today as a leading solution to climate change. EVs rely on electricity, which is a form of energy intended to be pure and moving away from gasoline, which is thought to be dirty and pollutive. But part of our objectives in researching is to remain unbiased, and what we discovered in conducting life cycle analysis was that the production side emissions from EVs pose significant threats to their favorability as both a short-term and long-term solution to emission-provoked climate change. Thanks to corroborating data from the Argonne National Laboratory and the Low Carbon Vehicle Partnership, we were able to identify many contradictions between the purported cleanliness of EVs and the reality of their unchecked production side pollution. Knowing the downsides of the alternatives and niche items proposed to combat emissions will provide us with a fuller view of the necessary changes and potentially better solutions in our fight against climate change.
To begin this investigation, we wanted to prove that the use of gas for fuel and current manufacturing methods are not feasible for the long term. Our data proves that the price of electricity will be stable over long periods of time. We can observe from the trendline for gas, which proves that gas prices will rise and will eventually be too expensive for the majority of the population to afford. On the other hand, Figure 6 shows us a graph which represents the price of solar panels and shows a steep decline in price for solar, and the trend line illustrates a further decline in the future, which is reasonable to assume since the shift to cheap renewable energy is gaining speed. Thus, solar will be mass-produced and/or imported at low cost to further decline prices, which will make solar much more affordable and more feasible.
It's clear that economically we are trending towards an electrified future, but it's important to consider what this means for the transportation industry and whether this is really a net positive or not when considering the true environmental impact of vehicle electrification after life cycle analysis. Data compiled and visualized below sums up the immense continued concerns regarding EV emissions. While the net impact of EVs is to reduce emissions, the production cycle is emission intensive, even more so than gasoline vehicles. This is clearly demonstrated by Figure 3, a three-dimensional bubble plot comparing vehicle weight, which is characterized by vehicle electrification, against the CO2 emissions and energy usage. From left to right, as vehicle electrification increases, production side emissions and energy usage do too. The same pattern is corroborated in Figure 2, where the net impact of electrification is for emissions to decline, but at the cost of greater production side emissions. Clearly, EVs are not satisfying their goal of being environmentally friendly, and change is required to the means and methods that they are being produced.
Solar power is not only affordable but also widely used. In the United States, solar power usage has increased from 0.34 gigawatts in 2008 to over 97.2 gigawatts today. Solar panels can be placed on any existing rooftop where typically the space wouldn't be used anyways. In addition, the cost of manufacturing solar panels have dropped by nearly 70% since 2014. This proves that there is potential for further reduction in costs as industries continue to innovate. Today, many new innovations in solar are taking place, further suggesting why solar power will be a viable long-term solution. In addition to the economic feasibility of solar energy are its corresponding environmental benefits. A study by Sierra and Rangers in 2020 portrays solar energy as the cleanest form of energy generation available. This study was carried out in 3 distinct geographical regions across the world.
Projections data give us a glimpse of how we're trending. We collected data from a project from Global Regions Data formed with a collaboration with World Business Council for Sustainable Development and the International Energy Agency in 2004. At the time, this data predicted the global emissions from vehicles till 2050 and for it to continue with a gasoline-based global market. Now, as a team, we have pinpointed the level of EV interventions serving as a remedy to global warming and have accumulated data on how EVs have changed global emission predictions. As we fast forward 16 years later, the IEA provided new projections from the year 2000 to 2070, suggesting a decline in emissions from 2020. Electric cars are growing in number year by year. According to data retrieved from the RFF and Bloomberg, the population of EVs was merely a few thousand in 2011 in the US. In 2019, globally, that number was about 5 million. So electric cars are needed considering these emission rates by cars provided by Our World data.
One of the biggest factors of rapid adoption of EVs is the price. To have a carbon-neutral world and stop climate change, we must have a green alternative which is affordable to the majority of the population and simple enough for us to implement right away. Thus, we have chosen that solar energy is the ideal source of energy. We have created 2 graphs which show us the price of cost per mile for electricity compared to the gas and the average price of gas within a long period of time. The data for these graphs were provided by the Bureau of Transportation Statistics of the United States of America and Statistics Canada. The graph on the left shows us a comparison of prices between electricity and gas over a 17-year period. The graph clearly shows a large gap between the prices and volatility between the two, thus proving that not only does electricity have a stable price, it is also the cheapest compared to gas and is the most feasible from a financial standpoint. The graph on the right shows a more concise visualization of the volatility of the prices of gas in Canada. As you can see, the change in price of gas is very volatile and cannot be trusted over a long period of time. As this data is provided from Statistics Canada based on gas prices in Canada, we can assume a similar situation in the United States as the economies follow a similar pattern.
Figure 5 provides clear and convincing data that suggests photovoltaic charging is conducive towards minimizing transport emissions. The graph on the left differentiates the amount of transport emissions produced by the same 4 vehicle types on the basis of the charging method in 3 major global cities. There appears to be a distinct and strong negative relationship between the vehicle's degree of photovoltaic charging and the amount of transport emissions produced. As the extent of vehicle solarization decreases in bars left to right, the transport emissions increase dramatically. Although the precise data varies, this general relationship is universally observed in all 3 locations across the world, with no deviation, suggesting that the data's pertinence carries over on an international scale and is quite expansive in its scope. And in greater reliance of EVs on fossil fuels is suggested, and for this, the method of production and generation of electricity are in dire need of examination and prompt change. Solar-powered EVs evidently show a capability of reducing the still immense emissions created by the highly popularized EVs. Lastly, to ensure long-term sustainability, we considered the effect of using solar energy versus its close rival, wind energy. We found that while wind is slightly more efficient than solar energy, the accessibility, durability, and affordability are what make solar energy marginally better. Innovations are constantly being made in the solar industry, and some of the latest technology include researchers trying to make transparent panels that can double as winds, doors, or even walls.
So we reached many significant conclusions. As a result suggest rising gas prices, unrealized carbon emissions, and inefficient methods of producing cars leads to excess emissions and prices. There's a demand for better ways of producing cars, electric batteries, and other alternatives such as solar and hydrogen power. However, the unexplained portion of our research is the long-term effect of hydrogen fuel and whether it will suffice for reducing emissions. Before we finish, we leave you with a quote by Elon Musk. In order to have clean air in cities, you have to go electric. Electric cars are our future, and we have to find ways to rectify the other factors. We would like to thank everyone who made it possible for us to make this manuscript, and a special thanks to STEM Fellowship and the Big Data Challenge Committee. Well, that is all for us, and on behalf of our team, thank you for your time. and see you on March 5th for Big Data Day.